Hello, everybody. So, we have reached step 3, phase 3 of protecting our body from outside influences and infections and pathogens. We have finally reached the most hardcore of systems called the adaptive defense system. Your adaptive defense system has 2 parts to it. We're going to go over the first part of it in this video, and then your final video will be the last bit, as well as some other illnesses and diseases to keep track of. Right? And I know we are talking about this, the whole system is talking about illnesses and diseases, but you'll understand when I get there. Right? So we are talking about your adaptive defenses. And I'm going to go ahead and apologize right now. My cat has decided that he wants attention, so he's trying to sneak in and move my microphone and crawl on top of me. So if you hear me suddenly pick up my cat and tell him to stay on his little bed, or you hear something knock over, I'm apologizing in advance. Because he has decided to be a little persistent cuss, like most cats do occasionally. Right? We love our purring fur balls, but sometimes they can be demanding and think they are gods. Right? So, your adaptive immune system is the line of defense where we have gotten away from regular cops. We've gotten away from our SWAT team of natural killer cells. We have finally gotten into our trained military personnel that need to deal with these threats to us. Right? So your adaptive immune system is for a specific defense system. Its job is to protect against infectious agents and abnormal body cells. It's going to amplify the inflammatory response that we had been discussing in the previous one. And it's also going to activate complement proteins, right? The 3 most important things you need to know about your adaptive response system, and you need to know these 3 things, is that your adaptive immune system is specific, it is systemic, and it has memory. So we are now talking about the formal, trained military defense system of your body that is going after specific threats. It is going after these specific threats system-wide. It's no longer dealing with a specific, you got a paper cut on your fingertip, we're only caring about your fingertip kind of deal. This is system-wide. Your whole body is involved at this point. And it has memory, so it can remember who the bad guys are. Right? So your adaptive immune response is specific, it's systemic, and it has memory. There are 2 separate overlapping arms of your adaptive response system, right? Remember, self-recognition, because it's system-wide, specificity, memory. There are 2 separate overlapping arms of this. You have a humoral immunity system. The humoral system is antibody mediated. That's when we get to start talking about our antibodies. And then we have a cellular, cell-mediated immunity. The rest of this video I may introduce parts of humoral, but for the most part we are discussing in this video the cellular, cell-mediated immunity. Your next video is going to be about the humoral process and the humoral system. And that's like the last end of your immune system. So this video we are going to focus on your adaptive cellular cell-mediated immunity. Right? We are also going to be talking mostly about large, complex molecules that are normally found in, or that are not normally found in the body. That is our target. Those are the things that we are going after. We need to go after larger molecules that your other systems couldn't handle, that are not normally found in the body. They are non-self. Right? So there are a couple of important determining processes to all of this for antigens, because antigens, remember, those antigens, if you remember, were your name tags on your cells. They were the self-identifying proteins on the outside of your cells, right? A lot of this is antigen dependent. We're going to be talking a great deal about that in this video. There are a couple of factors in determining all of this that we need to understand. Immunogenicity, that's your body's ability to stimulate and proliferate specific lymphocytes and antibodies. So your ability to make more lymphocytes, we're talking about T cells and B cells in this section, guys. So your ability to make more T cells and your ability to make more antibodies that come from B cells, right? We're also talking about reactivity, which is your body's ability to react when products of activated lymphocytes and antibodies are released. Because if your body can't react to the things that are being released, it's a moot point. And if your body can't even react to the cells because there aren't enough of those cells to react, meaning you don't have immunogenicity, you can't proliferate specific lymphocytes and that kind of thing, your body's also going to fail to respond to these threats to the outside world. Wink, wink, nudge, nudge. You guys already know of one very specific lifelong death sentence illness that greatly impacts your immunogenicity. I'll let you think about that one before we get there within the next video or two. But you guys already know at least one illness that affects that. Right? So some of the examples of chemicals and proteins and whatnot that we are going to be talking about and how they affect your body's reactivity and immunogenicity are foreign proteins, right? Polysaccharides, those are super complicated sugars, foreign fats, and foreign nucleic acids, right? Sometimes we may be talking about smaller molecules like peptides, nucleotides, hormones, that kind of thing, because some things your adaptive immune system will react to, others it won't, right? So some small molecules are not immunogenic by themselves, but they can become immunogenic when they attach to different body proteins, right? So by themselves, some things are not harmful in and of themselves, but when you ingest them, they become immunogenic, and then they are bad for you because they have combined wrongly with parts of your body and your body proteins, and then they do elicit an immune response, right? Sometimes these smaller proteins, which weren't harmful initially, can cause an immune system to mount a harmful attack against it, right? Sometimes a good example of these things that are not inherently bad out in the world, but that could potentially be bad for you, are things like animal dander. Animal dander is just the animal's dead skin underneath their fur, right? I apologized for my cat at the beginning of this video. I own dogs and cats. I am an animal lover. I'm fine with animal dander. I understand that my cat has skin cells underneath his fur that will flake off, and that is called animal dander. This is why I sweep and vacuum my house. Some people, though, even though that animal dander by itself is not that harmful, if it gets onto somebody else's skin, their skin and their immune system will freak out and begin to attack it because of how it interacts with the proteins in their own body. We say those people have an allergy to animal dander, right? So animal dander in and of itself is not harmful, but if the wrong person were to visit my house without telling me that they were allergic to animals, they may end up having a breakout. Some detergents fall into this, right? If I use Bounce fabric softener sheets when I'm doing my laundry, I will break out in hives if I wear the clothes that I washed with those. So that kind of detergent affects me, but I can use Tide or whatever else I want and it won't do anything. Some people are allergic to cosmetics, like some things in makeup, and that will make their skin break out if they're allergic to an ingredient in the makeup. So my mother has a strong reaction to poison ivy. So whenever she chooses to do yard work, like most people, you can go out in the yard and do your day of yard work, take a shower at the end of the day. You're exhausted, but the job is done and you're fine. If my mom does the wrong kind of yard work and she takes the lawnmower for her house and accidentally runs over a patch of poison ivy, and that gets up in the air around her, she's going to have like a full body rash for the next week because she has extreme reactions to poison ivy. Thankfully I did not inherit that, but for whatever reason, my mom reacts really poorly to poison ivy and bug bites. So some things in and of themselves are not immunogenic. They're not supposed to elicit an immune response. But sometimes when they mix inappropriately with the wrong person, they do. Right? The reason for this is because we are talking about antigens, right? So antigens are those little proteins that are on the outside of cells that I have referred to numerous times as name tags. So they are name tags for your cells that identify you as being or identify cells as being part of you. There are antigenic determinants out there. That means a certain part of the entire antigen are immunogenic or immunogenic, right? That means that lymphocyte receptors or antibodies can bond to them. So different parts that are made from your immune system can bond to different antigens. Right? This is how cells communicate. You literally have like T cell number 2 here with its antigen determinant can fit together like a puzzle piece upon this protein or this antigen, like this cell's or this protein's antigen determinant, and they can fit together and identify one another on a chemical level. And then this T cell knows to leave this protein alone. Right? That is how your cells and body identify and communicate with each other on a cellular level. Right? They have to make sure their little antigenic determinants fit together like puzzle pieces. Most of your naturally occurring antigens have numerous antigen determinants on them. So they're going to be able to identify multiple different antigens because different cells have multiple different antigens, right? So cells have different name tags and they may have multiple name tags. It's the same thing as you having both your driver's license in your purse and wearing your student ID when you come on campus, right? You have both of those forms of ID. You can't buy alcohol with your student ID, but you can get into the library and make copies with it. Right? But you need your driver's license for the alcohol. They won't accept your student ID to buy alcohol. But you still have both of those cards in your wallet. Right? You have multiple name tags or antigenic determinants on your person to identify yourself for whatever you need. Right? Right, so you're going to have multiple of these antigenic determinants on each cell, and they are going to mobilize several different lymphocyte populations. So if a lymphocyte or T cell communicates with a cell via these antigens, and a T cell notices, wait, this antigen is from an infection, right? Because T cells can recognize that information. They can multiply all of the lymphocytes that can recognize that illness. So you may have a T cell floating around your throat when you get the flu. If one T cell recognizes that one of the cells at the back of your throat is infected with the flu, that T cell will mobilize other T cells that can also recognize flu infections. Right? From this information, this will also then further trigger the humoral immune response to form different kinds of antibodies that fit on to these antigens. Because an antibody will fit onto antigens like a puzzle piece. Right? And one thing to remember, very large chemically simple molecules like plastics have very little or no immunogenicity. Right? So that means they don't have these little receptors on them, and your body pretty much ignores them. This is why, for example, some birth controls that you may see advertised, like on the television, like Implanon, for example, is a small, maybe 1.5 to 2-inch long plastic tube that you can place underneath your skin to give you birth control for long-term birth control. I know they show the actual Implanon device on the television, but they never show them implanting it under a woman's skin in their arm, right? Your body, because it's plastic, your body doesn't care. Your body ignores it because plastic does not have immunogenicity to it. It doesn't elicit an immune response. It's just this random thing that you just stuck under your skin. And that's fine. Right? This is part of the field and jobs that we do when we are talking about what materials should we make replacement heart valves out of. What materials can we use to build a pacemaker, right? We have to choose specific materials that have little or no immunogenicity to ensure that after we have given that nice little old lady her hip replacement, that the material we built the hip replacement out of is not something that her immune system will start to attack. That is a goal of biomedical tech and biomed design of materials, right? So some of these antigen processing or some of these antigens that we are talking about for your adaptive response system are for presentation. And some of these self-antigens that recognize things are called MHC proteins. So MHC proteins stands for Major Histocompatibility Complex molecules. These are all proteins. We're just going to call them MHC proteins. These are protein molecules that are self-identifying antigens on the surface of cells. Right? These are antigenic to others and transfusions or grafts. That means in a transfusion or a graft, if you are badly burned and you need to take a skin graft from somebody else, they have to double check that your body will not attack these MHC proteins along the sides, right? If you get a blood transfusion, these are some of the self-identifying antigens that the person's immune system is double checking against from a transfusion or a kidney replacement, an organ replacement, that kind of thing, right? These are some of the proteins that your body is double checking against, right? Because these are antigenic to others in transfusions or grafts, right? So when we are talking about your MHC proteins, these proteins are coded from our genetics by our genes for major histocompatibility complexes, and they are unique to an individual, right? So my MHC proteins are not the same as your MHC proteins. That means this is one of your body's ways of double checking that this tissue and these cells belong to you, and it is coded as a part of you and compatible with what your body does and your genetics, right? This is the point of it, right? And this can get rather complicated, but can also be super fun at the same time when we start talking about infections, right? So our T cells are designed to recognize MHC class proteins, right? And there are different classes of MHC proteins, right? This is where we get into the fun part. So, class 1 of MHC proteins are found on virtually all body cells. So, basically everything has an MHC class 1 protein on it. But then we have class 2 MHC proteins that are found on certain cells in the immune system. Right? So only certain cells in the immune system have the MHC class 2 proteins that are specific to your immune response that will respond to specific MHCs. Right? MHC class proteins usually display peptides that are self-antigens. For an infected cell, right, if you have a cell that's infected by the flu, for example, the MHC proteins that are displayed will display fragments of the foreign antigen, so they will display fragments of the virus, which help mobilize and recognize things within your immune system. This is where we start talking about, remember how I mentioned your macrophages were not only SWAT team members, but they also were detectives that gathered evidence? And your helper T or your T cells have to be able to identify specific threats? This is how. And this gets into the fun complex of MHC class 1 proteins and MHC class 2 proteins. Right? So an MHC class 1 protein, right, is on most body cells, but MHC class 2 proteins are found on certain cells of your immune system. What will happen, right? When you have your initial wound or initial infection, and those macrophages and neutrophils rush to the site to start cleaning up the mess and killing the bad guys, right? Because that was everything we talked about in our last video on that second line of defense. Those macrophages will go hardcore sociopath, right? And as they eat the microbes that are invading your body, or as they start eating and taking out the cells that were infected by the flu virus, if this is happening in the back of your throat, those macrophages will say, oh no, this is a prevalent infection, and these antigens definitely need to be seen by people, by my superiors and others higher than I am. This is not good. I need to tell someone else. So, using the MHC class 2 protein, the macrophage will steal the antigens from the microbes, rush to find a T cell, and then give those antigens using the MHC class 2 protein to the helper T cell who is identifying these microbes with an MHC class 1 protein, so that the helper T cell can mobilize a more effective and bigger specific threat alert against the specific antigen and microbe, and the T cell can alert the rest of the adaptive immune system. Right? So I'm going to repeat this once more. When your macrophage undergoes phagocytosis and eats a foreign microbe, it is going to steal the antigens on the outside of that microbe when the infection gets bad enough, use those microbe antigens to attach those to an MHC class 2 protein, and using the MHC class 2 protein will deliver the microbe's antigen or name tag to a T cell by attaching it from the macrophage's MHC class II protein to an MHC class I protein on the helper T cell. Right? If I am going to put this into movie, fantastic, sick military terms, right? Your macrophage here found the infected flu cells at the back of your throat and was going Rambo on all of them and eating all of the viral infected cells. And then he said enough is enough, and he took the skin of the infected cells with those name tags, and then using this MHC class II protein, presented the skin of the enemies to the T cells and said, this is our enemy, this is who we have to identify and fight. And then the helper T cell, using the MHC class I protein, says, this is a threat. Thank you, Private. I'm going to alert the army. Takes the skin of the enemy, those antigens, and runs back to mobilize a full military threat alert. So your macrophages are pretty hardcore, and they are literally using these class II proteins to take the skin of the enemy and the enemy's name tags and present them to their higher-ranking T cells. And the helper T cells are the T cells that communicate between other T cells and the macrophages, because they are the ones that bring messages back and forth. Right? So your hardcore macrophage is going to eat the enemy, but save the skin of the enemy, and then using its class II proteins, deliver it to T cells. Right? This is when things are going to get fun. Right? We know that our MHC class I proteins are found on all cells. They have a specific type of receptor on them called CD8 receptors. They are also cytotoxic T cells. That means they are T cells that are specifically looking for cell-toxic chemicals. You should remember that MHC class I is associated with CD8 receptors and cytotoxic T cells. Right? MHC class II proteins, however, are only found on immune cells. They are more professional. Right? They have receptors on them called CD4 receptors, and CD4 receptors are the receptors on top of the helper T cells. I recommend remembering that helper T cells have CD4 receptors, and that is part of your MHC class IIs. We are going to come back to mentioning CD4 receptors and helper T cells either later in this video or in the next video. Right? Because there's some interesting fun quirks specifically with CD4 receptors. Right? Especially on your helper T cells. Right? Right. This is going to get into some of the aspects of understanding the difference between humoral immune response and cell-mediated immune response. Right? Because you have two different types of cells within your adaptive immune system. We know that you have two different types of cells. Right? You had T cells, and the other type of cells are B cells. Right? If I'm going to tell you what both of them do for jobs right now, and then we are going to continue focusing on your T cells. Because B cells, when they start talking about antibodies, is for humoral immune response, which is where we are headed in your next video. So you have two different types of lymphocytes. Your B cells right here. Remember how when I introduced all of this to you, your B cells were more like the CIA agents in the background of things. right? They are your humoral immunity. So if we are talking about B cells, we are talking about the humoral immune system, right? Their job is to build and make antibodies. We will discuss that more a little bit later, right? On the flip side of things, the cell-mediated immunity uses T cells, or T lymphocytes. They were the ones that were SEAL Team 6. They are your Marines, right? You have a few different types, or 3 types of T cells that you need to know about, right? You have the natural killer cells that we have been discussing. They are part of your innate immune system, which is why we talked about them a lot in your last video. Their job is to kill viral infected cells and anything that has lost its name tag that is deemed not you, right? And then you have 2 other types of T cells that you should know about. The first one are called helper T cells. Helper T cells have something on them called CD4 receptors. That is the specific type of protein on the outside of them. And they act as messengers. They are messenger T cells. And their job is to run between the innate immune system, which is why we were just talking about them interacting with MHC class 1 proteins with macrophages and that kind of thing. And helper T cells act as the messengers between your innate immune system and your adaptive immune system. So your helper T cells are going to communicate directly between macrophages and other T cells and B cells, right? The other type of T cell you need to know about are called cytotoxic T cells. So your cytotoxic T cells are the other type of T cells you'll need to know about. Those ones act as assassins, right? So you can think about these guys as your special trained SEAL Team 6 force that are assassin cells. And these cytotoxic cells have CD8 receptors on them, and they are going to target very specific foreign invaders into your body. And they are either going to mark them with antibodies, just like Japanese police officers peg cars from high-speed chases with paintball guns, or they are going to find and kill previously marked cells. That is the entire job of your cytotoxic T cells. They are your secret killer assassins. They will find and kill and make their opponents commit suicide or apoptosis. They are going to evolve in response to viral infections, right? You also do have some T cells called regulatory T cells. They are going to be the ones that, how do I put this? They are the Interpol officers of all of this. So these guys are the ones that crack down on these other Marines and messengers and army men when they've gone too far and gotten too many. So the regulatory T cells are the ones that tell everybody to take a step back and it's time to pull out. They call for the retreat. Right? We all know that we have antigen-presenting cells, right? Antigen-presenting cells are cells that are going to present antigens to prove who they are. Or they are basically your macrophages. They are going to present antigens to these T cells, like the helper T cell, to help them detect who the bad guys are. So think about your macrophage. It's the SWAT team and it's the cop, but they handed over the evidence to the military who needed those details and that information, right? So a macrophage is an antigen-presenting cell. But that means that your macrophage, remember, your macrophage just presented the bad guy's antigen. Your macrophage do not respond to specific antigens. They're eating everything that is not you, right? Essentially, your macrophages are going to play essential axillary roles to adaptive immune systems while doing an innate immune system job, right? This is where we get into talking about specifically lymphocytes, right? Because we've met our nice T cells and B cells now, right? We're not going to talk about antibodies yet. That's your humoral system. So we're going to talk a little bit here about T cells and T cell development, right? So now that we have been introduced to everything we need to know, we're going to talk about our T cells. We've talked a little bit about them before and where they come from. Lymphocytes, if you remember from way back when, develop and originate in your red bone marrow. But B cells are going to mature in the red bone marrow, which is why they're called B cells. They matured in the bone. But T cells are going to move out and mature in the thymus, which is why they are called T cells, because they matured in the thymus. When your T cells have fully matured, right, they have gained self-tolerance. That means they are unresponsive to self-antigens, meaning they are not going to attack things that they deem as part of themselves. And they will be immunocompetent, meaning they will be able to recognize and bind to specific antigens that are not you. Meaning, hopefully, when they are done training in your thymus, they will be immunocompetent and be able to recognize a foreign agent and attach to specific foreign agents, but also be tolerant of yourself and not attack you. Right? Because their job is to protect you. You don't want to attack the thing that you are protecting. Right? So the way all of this works, if we want to summarize this, is these naive or unexposed B cells and T cells are going to live in the lymph nodes for a little while. They're going to go to your lymph nodes, your spleen, other lymphoid organs, thymus, that kind of thing, wherever they are maturing based upon the type of cell they are. And this is where they essentially are going to go to boot camp to become the members of the CIA or military that we have been discussing, right? They are going to become self-tolerant and immunocompetent. They have to be trained. Meaning your T cell has gone to the thymus, and they are going to be exposed to other antigens. The B cells are going to stay in the bone marrow and be trained there, and they are going to become immunocompetent. However, your B cells are going to still be considered naive until the next wave of training, when they start being exposed to antigens in lymph nodes. That's where they're going to basically go from having book-smart basic training to going on active duty, is when they are sent to the lymph nodes. The lymph nodes is their first test of reality. You got through basic training. Can you deal with the real world active duty kind of thing? Right? The next step up is active duty, where they are both immunocompetent, and they aren't naive anymore. And they can identify themselves, which means that they can free float within the bloodstream, where essentially they are acting as full-fledged military agents, and it's kill or be killed. Right? So T cells, when they are specifically maturing in the thymus, they're going to have negative and positive selective pressures placed on them in order to be deemed competent. Right? So your T cells are going to be evaluated strenuously. They have positive selection, which is good. If they are positively selected, that means they can recognize what is self and what is not self, so they do not attack yourself. Right? This is what positive selection essentially means. They're going to have thymic epithelial cells here start attaching to these these immature T cell receptors, right? And see how well your T cell responds to them, right? So, positive selection, right? If they do good, that means that your T cell can recognize what is yourself and what is not yourself. right? If you are capable of recognizing things that are yourself and the T cell does not attack or respond to the self-identifier, it moves on to the next step. This means that this is going to select T cells that are capable of binding to self-MHC class proteins. This is how they talk, after all. Remember, those MHC class proteins binding together is how your cells were talking back and forth to one another. That's why we just talked about that for a little while. If your T cell refuses to use the MHC class protein, or they're shaped wrong, it's deformed, and it cannot hook up and attach to other MHC class proteins, that T cell cannot do its job, it can't do the military job, it will die. Other cells in your immune system take it out and kill it. We're talking like this is extreme selective pressure, remember, right? And a T cell that goes rogue is bad for everybody involved, right? You don't want it not being able to recognize what is part of you. So your T cell that goes rogue that cannot attach to anything, it's like, see that little X out there? It dies, right? So positive selective pressure, yay, it can understand what is part of you, and it will recognize and respond and attach those MHC class proteins. Right? After this point, it's going to get its CD8 receptors or its CD4 receptors. It has passed on to the next level of training, which is called negative selection. Right? Your negative selection part of this tests bad stuff, right? So this is going to check to see what your T cell attaches to and attacks. If the T cell kills if your T cell binds and attacks to anything that does identify as self-proteins, so it starts binding to self-proteins, right, and attacking self-proteins, that's bad. That means it's going to be killed off, right? So first you had positive selection. Can the proteins even attach to each other? Yes, they can. You move on to negative selection. And negative selection is essentially checking, are you smart enough to know who to shoot? Right? As far as military training goes, that's pretty self-evident, right? If you have one idiot that has gone to boot camp and is just wildly firing his gun, and is a risk to, hitting everybody with friendly fire, you don't want him to be on the front lines in active military duty. He's stupid, and he's gonna kill the entire battalion with friendly fire. He's that one jerk in your, Call of Duty game that, shoots, drops a hand grenade on the entire team and nukes the entire team. You don't want to play that video game with him anymore, right? You don't want that dude on your actual military team. This is what this is double checking, right? So positive selection was, can you recognize and bind to good things and self-antigens? Checkbox yes or no. And when the answer to that is yes, you can bind, you move on to the negative selective pressure. And your negative selective pressure tests to see if you will attack self-proteins that you can attach to, right? This is going to, if your T cell here not only it can attach to the self-receptors, but begins attacking them, it's going to these cells here and these dendritic cells are going to prompt cell apoptosis of that T cell because it's intolerant and is a friendly fire risk to everybody involved. It's stupid and it doesn't know who to kill, so you can't let it loose in the military with a gun. If I can put it that simply. So negative selection is, will you attack the correct people? Checkbox yes or no. If the answer to that, once again, is, I have attacked the wrong person, no, I don't know who to attack, your body will kill those T cells, and that's that. But if a T cell passes this check to see if they're stupid or not, or if they do bad, then congratulations, they get to move on to the next phase. Right? This double round of checking, the positive selection and the negative selection rounds, is your body's way of ensuring, right? It's your body's way of ensuring that your T cells are self-tolerant and will not attack yourself. Because you do not want your immune system attacking yourself. Right? That would be bad. No good can come from that. Right? So all of these lymphocytes make up about 1 billion different types of antigen receptors. Right? They have 1 billion different types of antigen receptors that they can read. This is coded by roughly 25,000 genes in your genetic code. So some people are better at identifying these things than others. It's a genetic thing, right? Your gene segments are shuffled by somatic recombination when you are making your egg or sperm cells, which determines what passes on to your kids, right? So your genes and your base genetic is basically going to determine which foreign substances your body like your immune system recognizes and resists. This is why some people are better than other people at recognizing some illnesses, and why some people, like for COVID, for example, this is why you hear in the news, like some people are arguing this is just a really bad cold, whereas you have others who are in the ICU dying from it. We don't know what proteins COVID attaches to and how it affects people. There is likely a genetic component to all of this that is yet undiscovered because we've been dealing with this for less than a year. But for whatever reason, there is a genetic component to this. And for some people, COVID is a really bad cold. And that will feel like your flu has a cold. That will knock you back on your butt for a few weeks, and then you move on. But for other people, like I had one friend, and she is a smoker, and COVID hit her, and it was like that. She says, oh, it's not that bad. It's like a really bad cold. And she moved on. Done deal. My other friend that has had COVID, though, does not smoke, right? So smoking was not the only factor at play here. But for whatever reason, when she caught COVID, she had a super high fever for 3 weeks straight, and she had COVID back in February or March, and she still has difficulty walking across the room now. She will get out of breath walking across the room or walking across church. Whatever hit her, or whatever differences between their two bodies is probably genetic, but COVID hit one friend much harder than the other and has probably dealt some lasting damage to her, considering she can't walk across church now, 8 months later, without getting out of breath. This is one of the things that scientists are researching, and why you have people asking you to wear face masks and be more empathetic toward others, because we don't know. We haven't done all of the research. We haven't had the time to do all of the research. We don't know why COVID hits some people like a Mack truck and other people not as badly. We haven't discovered those genetic links yet. And this is why others are asking people to socially distance and wear face masks and whatnot. Be kind to each other. Hopefully everybody that we're talking to will turn out okay. But that's what people are asking. They're asking for some consideration in this, because you don't want to inadvertently negatively affect someone that just simply doesn't have the genetic heads up that you do, if that makes sense. Right? Right. So we talked a little bit about these antigen presenting cells. We've mentioned macrophages a great deal. You have a couple of different types of them in your body, though. Dendritic cells are also a different type of them. They are in connective tissues and epidermis, like your vaginal canal and that kind of area as well. you have a number of dendritic cells there. We've talked about your macrophages in great detail, and they also hang out in your lymphoid organs. We know that those are where antigen-presenting cells kind of hang out and live, right? And their job, once again, is to take, using their MHC class II proteins, their job is to take the antigens from the cells that they, or from the pathogens that they eat, and then present them to helper T cells. Right? So they want to present these antigens to active helper T cells. Macrophages mostly are going to remain in the fixed locations, like remember macrophages like to live in specific organs. They're going to stay in their specific organs if they are specific type. Dendritic cells internalize the pathogens, and then they enter your lymphatics to present antigens to T cells. So your dendritic cells are more likely to go find or to go seek out a helper T cell. Right? And activated T cells are T cells that are on active duty, right? They're going to recognize this threat, take the antigen, and start releasing chemicals that are going to prod more macrophages or dendritic cells to become super hungry and far more insatiable, right? So they're going to go into overtime on their phagocytosis and start eating everything in sight while secreting all of the bactericidal chemicals that we have talked about them excreting. So your activated T cells, once they've been presented with these foreign antigens, are going to amp up the macrophages and say, good job, keep doing your job, do it harder and more. Right? So your summary of this cell-mediated adaptive immunity is that it's going to use lymphocytes, right, and antigen-presenting cells, and specific molecules, or the antigens, to identify and destroy anything that it deems a non-self substance. Depending upon the ability of the cells, it's going to recognize antigens by bonding to them, and it's also going to communicate with one another so that the whole system can mount a specific threat or a specific response from the threat to whatever is infecting you. And then from there, we get into the humoral system. I will see you in the humoral system in the next video.